Welcome back to my channel and welcome to Microbiology. In this video, I am going to discuss the effectiveness of heat as a sterilizing agent. Two important topics will be discussed here. First, why heat is very popular to sterilize different materials. Number two, the parameters used to describe the effectiveness of heat like decimal reduction time, thermal death time, and thermal resistance constant. So let's start. We know that heat is very effective and popular method to control the number of microorganisms. It is cost effective and rapid than any other physical sterilizing agent. It's possible to kill vegetative cells as well as comparatively tough endospore. For this reason, various food and pharmaceutical industries use this technique to control the number of microorganisms. The effectiveness of heat depends on several factors like type of organism present, bacterial load, temperature, time of treatment, medium, and pH. So it's clear that if we treat the medium for a longer period at a high temperature, we can able to kill all the organism. When exposed to heat, the death rate of microbes follows first-order reaction kinetic, and it can be described by a straight line with negative slope on a semi-logarithm plot. This plot is called thermal death curve or death rate curve. We can see the difference of death rate between heat-resistant and heat-sensitive microorganisms, as well as when the bioburden is lower. Microbiologists often used three parameters to describe the effectiveness of heat as a sterilizing agent. The most important parameter is called decimal reduction time or the D value. It is defined as the time required to kill 90% or 1 log cycle reduction or 1 decimal reduction of the initial microorganism at specific temperature and conditions. The unit of D is minute and the temperature is given with a subscript like D100. It tells the processing time required to sterilize the sample. D-value is generally calculated directly from the thermal death curve. Here in this hypothetical graph, I have found out the D-value. You can also calculate it mathematically using this equation, where T is the time, C0 is the initial bioburden, and C is the final bacterial load after heat treatment. Here, I have solved a numerical problem that appears in the GATE examination. I have used the equation to solve this problem. You can pause the video to watch how I solved this. Another important parameter is called the thermal death time or in short TDT or F value. It is time required to kill specific number of microorganisms under defined condition. It is generally expressed as multiple of D like 5D, 12D, etc. The F value is very important for canned food and shelf-stable food. F value is calculated easily from this equation. Most industries use 12D heat treatment to kill Clostridium botulinum spore at 250 degree Fahrenheit or 121 degree centigrade. Z value or thermal resistance constant is the increase of temperature to decrease 90% of D. It is also called thermal resistance constant. Large Z value means sample should be treated for a longer duration. Z value is calculated easily from D versus temperature curve. Here, Z value is the 1 log cycle change in D, or you can calculate it using this equation. The last and most important parameter is called probability of non-sterile unit or sterility assurance level or probability. This parameter told us that what is the probability of spoilage in a batch. It is calculated using this equation. Here in this problem, I have calculated the probability of spoilage out of 10 to the power 15 canned product. Again, you can pause the video to watch how I solved this problem. If you like this video, don't forget to subscribe, like, share and comment. And thanks for watching.